Welcome to the Lionheart Academy. This is Richard Tai. Today we're continuing our trigonometry lesson 48. We have been working on solving oblique triangles. Now, on our last lesson, we worked on the first case, which is angle, angle side, or angle side angle, which is when you are given one side and two angles. But today we're going to be working on the a very important case. It's called when we're given two sides and an angle opposite to one side. Alright, so let's go ahead and take a look at what we are given. Okay. Now, in this case, we're going to be using the law of sine to help us solve it. Now, some people call it the ambiguous case. Actually, I don't think it's ambiguous because we have a set of rules that can tell us exactly what we're looking for. But there are different outcomes that we need to check on. So that's why we have many different cases. It's a little bit more complicated than the other cases. Alright, so let's see. What are we given here, right? So first, we're given one angle. So let's say we're given any kind of angle here. Let's just draw a particular angle here. Let's say we're given angle A, and then we're given a segment side A and side B. Okay, their lengths can be different. Okay, but side A is the opposite side, and side B is one of the adjacent side of angle A. That means side B has to be part of the angle A. Okay, either this side on the top or either on the bottom. Doesn't matter. But side A is the opposite side. It has to be on the opposite away from angle A. Because the given information, we may or may not be able to make a triangle. And then based on the information, there are many different possibilities, different kind of triangles that we can make. Okay. So, for example, let me go ahead and show you. I'm going to show you there are different ways to do this. First of all, the best way to understand this is let's consider angle A first. Okay, so we're going to start with the simpler case. Let's say angle A. Okay, so if angle A is greater than 90 degrees. Let's say the angle given to us was an obtuse angle. So like this. This is what obtuse angle looks like. Okay. Alright, so let's go ahead and consider that. So this is angle A, and let's say this is side B. Alright. Now, then let's consider this side A. Alright, the side that I'm free roaming here is side A. So as you can see, if side A is shorter than if this side A is shorter than B, then I'm not going to make any triangles. Right? You see, I won't be able to make a triangle. Now, if side A is the same size as side B, I still can't make a triangle, because if I go ahead and draw an arc, if you can see like that, this is an arc, I would only be coming towards the vertex of A. I won't be able to make a triangle. So the only case, if angle A is greater than 90 degrees, that we will be able to make a triangle is that A is longer than B. Do you see that? If A is longer than B, okay, now it's longer than B, I can go ahead and close up here. So that way, I will be able to make a triangle. Okay, so the situation is this: if angle A is greater than 90 degrees, we will be only make a triangle if side A is greater than B. If side A is greater than B. Okay, so that's one of the conditions. Alright, now what if the angle given to us is equal to 90 degrees? Okay, that's a possibility. So let's draw a 90-degree angle. Okay, we're considering all possibilities. Okay, so this is a 90-degree angle. Angle A is 90 degrees, and this is side B, because B is adjacent to A, is part of A. Alright, so in this case, what does A has to be? How long does A has to be compared to B? Now, this is the opposite side. So as you can see, if A is shorter than B, I'm not going to make a triangle either. If A is the same size as B, I still won't make a triangle, because it's not going to intersect the bottom line, right? The bottom segment. It can't. So again, A has to be longer than B. You can see that? It has to be longer than B, and then I can make a triangle. Okay? So that's the only possibility, that A has to be longer than B. Okay? So, and A has to be longer than B. Let me rewrite A. A has to be greater than B to have a solution. Okay, a solution, that means to make a triangle. And same thing here, A has to be greater than B. And when you have A greater than B, then what kind of triangle you have? You have a right triangle, right? Here you have a right triangle. And if A has greater than B, then we have the oblique obtuse triangle. Excuse me, obtuse. obtuse triangle. So those are the simpler cases. Okay. Now let's go ahead and consider the common case. The most common case is that what if the angle given to us is less than 90 degrees? What if the angle given to us is an acute? Alright, so if angle A is an acute angle is less than 90 degrees, then let's consider several possibilities. Alright, I'm going to draw angle A here like this. Alright, so this is an acute angle, angle A, and side B is here. Alright, so let's consider what's going on here. Alright, I'm going to draw A. Now if A is shorter than B, okay, A is shorter than B, then there are several things that could happen. But let me go ahead and, in order for me to really make this work, I need to draw another line. I need to draw a height of the triangle. This is the height of the triangle. Okay, so let's call this H. Now what is H in terms of angle A here? Now angle A, right, you see, if you draw the height here, the height is actually the opposite side of angle A, and B is the hypotenuse of angle A. So sine of angle A is H over B. So that means H is equal to B sine A. Okay, A. So the height of the triangle will be equal to B sine A. Okay, B times the sine of angle A. Angle A is the given angle here. Okay, so let's compare A. So let's say A is shorter. Okay, hold on. Let me go ahead and use a different color. Let me use a different color here. So let's say this is A, right? Oops. Let me go ahead and go to the top. Alright, so A starts here. If A is shorter than, you can see if A is shorter than H. If A is shorter than H, you are not going to make any triangles. There's nothing. Okay? So if A is shorter than H, shorter than B, shorter than H, shorter than B, of course H has to be less than B, because the greatest value sine A is going to be equal to 1 at 90 degrees, but then 90 degrees that's going to be not our case. So if A is shorter than H, shorter than B, then we have no solution, no triangle. Okay, and let me go ahead and draw another one so you can see a little bit differently. So this is angle A. Alright, let me draw the hypotenuse, not the hypotenuse, excuse me, the height of the triangle. Okay, so this is angle A, this is side B, this is side H. Alright, it's the right angle. Now what happens if side A, the opposite side, oops, make it solid here, the opposite side is equal to H. Now as you can see, if I can go ahead, if it's equal to H, then it has exactly one solution. Alright, so let me call this opposite side A, opposite side A. So as you can see, if A is equal to H, okay, if A is equal to H, or B sine A equal to B sine A, then there's one solution. One solution is actually a right triangle. Right triangle. Okay. Alright. And then let's consider the last scenario. Okay, so this is angle A. Alright, this is side B. I've been making side B a little longer, but that's okay. It works. Okay, I see this one. You can take a look at. Alright, so this is H. This is a right angle here. Alright, so let's go ahead and draw side A and see what happens. Now, if side A is longer than H, right? Longer H but less than B. Now, if it's longer than H, okay, like here, you can see it's longer H but it's shorter than B, then you will see that it will intersect the baseline at two places. One towards angle A and one away from angle A. You see that? Because you can see the swing of the arc, right? There's a swing of the arc will intersect it like this. So when I swing the arc, when I swing this A, okay, whoops, side A here and side A here, it will swing over and it will intersect at this point, at this point. So what happens here is this is point B and this is point B prime. So what happens is this A, when A is between the H and the length of A is between H and B, it will intersect the baseline AB twice. And then it can intersect twice. That means it will be able to form two triangles. So in this case, if A is greater than H but less than B, so if A is greater than H is less than A is less than B, then we have two solutions. So this is a special case. We have two solutions, and one obtuse and one acute. One obtuse and one acute triangle. So there will be two triangles, obtuse and acute. You can see AB prime C, this is point C. AB prime C is an regular acute triangle, but AB prime, I'm sorry, I said it backward. ABC is acute triangle. AB prime C is going to be an obtuse triangle. Angle B here is going to be obtuse. So this is a possible scenario also. Now, if A is greater than B, okay, of course, if A is greater than B, then we will only have one solution. So let me draw that again. So let's say we have angle A here, side B here. Okay, so angle A, side B, and you have the H, right? The height of the triangle. The height of the triangle. Okay. So this is H, and then you have the side A. Okay, so let's say side A is longer than B. As long as A is longer than B, then I can go ahead and definitely make one triangle. Now, why cannot make two triangles? Because this side is longer than A, so when I swing over, there's nothing here to intersect. So then we'll have, if so here, if A is longer than B, if A is equal to B or A is greater than B, then we will have one solution, okay? One solution for both of them, and then it will be an acute solution. So there are several ways we can deal with this, but let's go ahead and use a table, okay? I'm gonna go ahead and show you a table to organize this information. I know there's a lot of information here. You can pause this and try to write this down, but let's go ahead and use a table. I'm going to give you a table very quickly, and so let me pause this and let me set up the table first, and we'll come back. Alright, so we're back with an angle here. So the columns, we're going to use the angles, okay? So first, measurement angle A, first column measurement angle A is less than 90 degrees. That means A is acute, okay? A is acute. The second column is measurement angle A is equal to 90 degrees. That means angle A is a given angle is right angle. And last column is measurement angle A is going to be greater than 90 degrees. That means the measurement the angle is obtuse. Okay, so we have three columns here. The first row will be when A is greater than B. Now, pay attention. A is the opposite side of angle given. Okay, so A is the opposite side of angle given. So if they give you angle B here, and then we have to switch B and A here. All right. So if A is greater than B, then there will always be one solution. All right. One solution, one solution, and one solution. And it will be a acute angle triangle here, a right triangle here, and an obtuse triangle here. Now, if A is equal to B, okay, if it's an acute angle, then we still have one solution. Okay, one solution. But if A is equal to B, if we have a right triangle and we have an acute triangle, then there will be no solution. So no triangle here. We cannot make any triangles if this is the case. Alright, the last column is A less than B. Now, I divided this further into three subcategories. Now, if A is less than B, then it could happen that A is less than H. B sine A. I'm going to write B sine A. That means H. Or A is equal to B sine A. Or A is greater than B sine A. Okay, and B sine A is the height. Is B sine A. Now, if this is shorter than H, then there's no solution for the acute triangle scenario. If A is equal to B sine A, there's one solution. That was a right triangle. And if A is greater than B sine A but less than B, then there are two solutions. And then the two solutions, one would be acute, one would be obtuse. Now, but if A is less than B, for both the right angle, there will be no solution, and there will be no solution for the obtuse angle given. So this is a great table. It summarizes very easily for you what to look for. So every time you deal with a case 2, you start with the angle. Okay, you ask yourself, what is the angle given, and then compare the opposite side of the angle with the adjacent side. After you make the comparison, then you can go ahead and find out just by looking at the table how many solutions you have. Once you determine the solutions, then we can go ahead and and solve it. All right, so let's go ahead and take a look at some examples. All right, you can pause this and copy this down, but we're gonna go on right now, and let's take a look at some examples of case 2. All right, so solve triangle ABC if side A equal to 4 inches, side B equal to 8 inches, and angle B is 21 degrees. Let's use angle A to be 21. Let's use just angle B. Angle A is 31 degrees. Okay, 31 degrees. All right. So let's first of all take a look at the situation here. The angle given to us is angle A. So the opposite side is A, little a, and then adjacent side is little b, the side next to angle A. And this is an acute angle. So we have to compare A and B. So A is definitely less than B. Okay, so you say, okay, measurement of angle A is less than 90 degrees, right? So if we go back to our table, we need to look at our first column. And A is less than B. Once we know A is less than B, then we need to compare A to B sine A. That's the height of the triangle. Okay, height of the triangle. So A is less than B. Okay, so then we need to compare A to B sine A. So this time we have to make that calculation first. So A is 4. B sine A is B times sine of 31 degrees. Okay. So let's see what is that. 8 times sine of 31 degrees. That is 4.12. 4.12. So A is less than that. Now, because A is less than H, this is B sine A is equal to H, the hypotenuse, not hypotenuse, excuse me, the height of the triangle. So what's our conclusion? All right, let's go back to our table just right here. A is less than B and A is less than B sine A, so there is what? No solutions. You cannot make a triangle because A is too short. No solutions. No solutions. Okay? Now, that's an easy case. Alright? So let's try another one. Example 2. Okay? We're going to try several cases here. Solve triangle ABC. Okay? So if A is equal to 4 inches, I'm still going to use this information. B is equal to 8 inches. But let's say angle B is equal to 21 degrees. So there's a little bit different information given to us. Now, the triangle ABC. Now, even though our tables is always use angle A and side, but in the problems it can be different. Okay, so let's go ahead and think about this. Now, the given angle is angle B. So measurement angle B is less than 90 degrees. So that means we're still looking at our first column. But instead of comparing A to B, we have to switch our thinking. We have to compare B to A because B is the opposite side. and B is greater than B is greater than A, right? Because B is 8 inches, A is 4 inches. So we are going to with this category, and so that's one solution. Again, why is that? Because B is the opposite side of the angle given. If they give you angle B here, we need to put B here first. We need to compare B with the other side. So because measurement angle A is less than 90 degrees and B is greater than A, so therefore we have one solution. Alright, so let's go ahead and take a look at one solution. How do we solve this? Alright, let's make a sketch. We know it's going to be acute, so this is 8, this is 4, right? So we're making it as proportional as possible, right? Oops. Actually, made a mistake. So this is 4, this is 8. Yeah, that's right. So angle B here, I'm gonna put angle B here, 21 degrees. Side B is equal to 8, and side A is equal to 4. So as you can see, B is longer than A. Then we definitely have a solution here. So we need to solve for angle A, angle C, and side C. All right. So how do we go ahead and use? How do we solve it? We use law of sine. Okay. So first of all, we have side B and angle B with side A, but we don't have angle A. So what we can do is we can set up angle A over A, sine A over A equal to sine B over B. Okay, so we can cross multiply to solve for sine A by multiplying both sides by little a. So A times sine B is divided by B is equal to sine A. Alright, let's substitute the information here. So it's 4 divided by A times sine of 21 degrees is equal to sine A. So that means angle A is the arc sine. We have to do the arc sine of this number here, 4 divided by A of sine of 21 degrees. That will give us the measurement angle A. Now we know angle A should be an angle in the first quadrant because it should be acute, so we don't have to worry about adjusting the numbers or anything like that. So let's go ahead and multiply that, and let's do the arc sine. Alright, after you do the calculator, it should be 10.32 degrees. 10.3. Let's go ahead and round it up to 10.32 degrees, or 10.3 degrees. That would be fine. Okay, so it's 1/2 of sine of 21, and that's 10.3 degrees. So it's actually quite small. Okay, that's fine. All right. So and measurement of angle A is 10.3. So that means measurement angle C is 180 degrees minus 21 degrees minus 10.3 degrees. So that will be 180, 21, 10.3. That's 148.7 degrees. All right. So we got those two angles, and the last side we need to solve is side C. Now we use the law of sine again. Okay, so sine C over sine C equal to sine B. I'm going to use sine B over sine B, just like before. Then little sine C will be B times sine C divided by sine B. So it will be 8 inches times sine of 148.7 degrees divided by sine of 21 degrees. Okay, 21 degrees. So sine of this, sine of 21 degrees, divide that times 8. So it will be 11.597 or 11.60 inches. Alright, so that seems to be the measurement of the sine C. So let's go ahead, pause right here for a moment. Alright, now let's do one more example here. Given, okay, triangle ABC. Okay, so let's say side A is 5 inches and then side B is equal to 8 inches, and measurement angle A, let's say, is equal to 40 degrees. Okay, alright, so let's check. So measurement angle A, we know according to our table, is less than 90 degrees. Alright, it's just less than 90 degrees, so it's acute. And so we have to compare A to B. Now A is less than B, that's great. Now we need to compare A to sine B sine A, which is the height of the triangle. So A is 5, B sine A is B sine 40 degrees. Alright, so let's go ahead and try that. So sine of 40 degrees times 8, that gives us 5.14. So 5 It's less than, okay. I guess I was trying to make into a case 2. So let's go ahead and change this to 30 degrees. Okay, I'm sorry. Let's change that to 30 degrees. Alright, so this will be 4. Okay, because sine of 30 degrees is 1/2. Sine of 30 degrees is 1/2. So A is greater than B sine A. Alright, so that means we have 2 solutions. Alright, so I want to show you how to approach 2 solutions. So let's go ahead and draw a triangle here. We know it's going to be A is 5, right? A is 5, and B is B is 4. So there can be a situation like this, and there can be a situation. Let me use a different color here. Then we can get a situation like. Oh, hold on. 30 degrees. 30 degrees is 4. B side B is 4. Sine A is 5. Okay, so it's kind of like this. And this. Okay. Alright, so angle A is here. Okay, angle A is 30 degrees. And this is side B equal to 4. And side A equal to 5. And so this is also A equal to 5. So you can see we have several situations here. We have angle B here, and we have angle B prime. So we have 2 solutions. So let's go ahead and solve for the first solution first. So solution 1. Now solution 1, what we're going to do is we're going to solve B as an acute angle. Alright, so how do I solve for angle B? Well, you remember sine angle B divided by B is equal to sine of angle A divided by A, right? So sine of angle B is going to be equal to B divided by A times sine A. So that means angle B, measurement angle B, is going to be equal to arc sine of B over A times sine A. So let's plug in the numbers. It's going to be equal to arc sine B over A. Now little b is 4, A is 5, sine of angle A is 30 degrees. Alright, so let's do that. So 4 divided by 5 times sine of 30 degrees. Alright, and do arc sine. So that will turn out to be 23.6 degrees. So this is measurement angle B is right here is 23.6 degrees. But what about solution 2? Okay, I'm going to talk about this together, because what is B prime? Well, B prime has the same sine value. Okay, sine of B prime is also equal to this. Is equal to the same value here. So sine of B prime is also equal to B over A times sine A. It's the same value, but the only difference is B prime is a obtuse triangle, is an obtuse angle, and it's in quadrant 2. So compared to this angle, how do I go ahead and do this? Well, if you remember, if my B is here is 23.6 degrees, okay, there's a B prime here in second quadrant that has the same sine value, and this reference angle is also 23.6 degrees, okay? So that means we have to do 180 minus 23.6. So B prime will be 156.4 degrees. So B prime is actually equal to 180 degrees minus B. Alright, so that would be 156.4 degrees. So that's what this angle is. That the prime B prime angle is 156.4 degrees, which is a lot larger, which is a second quadrant, and that makes sense. So based on this, then we can go ahead and finish both solutions. Alright, so for sine C, we need to for angle C, right? So to solve for angle C, we need to take 180 minus angle A, which is 30 degrees, and minus angle B, which is 23.6 degrees. So measurement of angle C will be 180 minus 30 minus 23.6 degrees. So it's 126.4 degrees, which makes sense. Angle C is obtuse. And so sine C over sine C is equal to B over A over sine A. Alright, so little sine C will be A times sine C over sine A, will be equal to A was 5, right? 5 times sine of 126.4 degrees divided by sine of 30 degrees. So let's go ahead and plug in that. So sine divide, and then times 5. So that'll give us 8.05 inches. All right, so that's the solution for that's the second set of first set of solutions. Now second set of solutions, this is angle B prime already, so let's go ahead and set for angle C prime. So it's 180 degrees minus 156.4 degrees, and minus 30 degrees. Hold on, this doesn't seem right. Okay, it seems that we're getting a little ahead of ourselves. Oh, that's very interesting. Let me see, 4 divided by 5. 4 divided by 5. Oh, okay. Yeah, I think B is 8. Oh, okay. I made a mistake here. Because I used 4 instead of 8. Alright, ladies and gentlemen, I'm sorry. This should be 8 over 5. Okay, so let's correct that mistake. 8 over 5 times sine of 30 degrees. Alright, so and then do the arc sine here. So that would be 53. So actually, angle B is 53.1 degree. I apologize. Angle B is 53.1 degree. 53.1 degree. Yep. 53.1 degree. So this angle is now 156. This angle is now 156. So this angle is actually angle B prime will be 180 minus 53.1. So it's 126.9 degree. Okay. So I have to correct all this as well. Okay. 53.1 degrees, and correct that to 180 minus 30 minus 53.1, so it's 96.9 degrees. Alright, so let's go ahead and change this to 96.9 degree. Alright, so the measurement here should be a little longer. So sine 30 divided by that times 5, and that'll give us 9.93 inches. Okay. Alright, so let's go back to here. So we subtract 126.9 degree minus 30. Now the reason I find out that was wrong, because we will get negative angle for angle C here, C prime. So 126.9 and then 30. So C prime is 23.1 degree. So little c prime is over sine big sine C prime, and equal to little a over sine A. So after we solve this, little c prime would be a times sine little c prime, big C prime, excuse me, angle C prime divided by sine A. So what that will be would be 8 times sine C prime, which is 23.1 sine times that divided by sine A prime 30. Multiply that together, so it's 1.57 inches. Okay. I do apologize for the mistake. Okay, so let me pause a little bit right here. So we'll go ahead and try another example. I know the videos are getting too long, but we'll try another examples on this later in the future. Please leave any questions and comments, and then we'll see you in the next lesson.